Hello everybody, welcome again. So today we're gonna be checking Ohm's law now, electricity, question 8. So now still on November 2023. So now we have a circuit. So the circuit diagram below shows a battery with an EMF of 12 volts, the maximum energy provided by the battery. Okay. And then in an internal resistance of 0.5 ohms connected to the three resistors. Then you can see the three resistors, right? And a light bulb, a switch, and a connecting wires. So now, as you can see there, let's analyze the circuit. We simply have a parallel circuit here, and then now if we find the resistance of this parallel circuit, we'll now have a series circuit, and then add the two ones, then the resultant number will now be parallel to what? To this 15 ohm resistor. You will see what I'm talking about when I'm gonna be doing the questions. Okay, so now switch S is initially closed. So when it is initially closed, this simply means that what? There is current flowing. Now Ohm's law, the current is directly proportional to the what and in the what it is directly proportional to the what is it, but you know it, right? Yeah, I don't want us to waste time on the definitions, because those are free maths that you can get for yourself. And then now what we simply have again, we simply have the first calculation. The first calculation is saying the total external resistance of the circuit. So now what we're simply gonna calculate now, we are gonna start by calculating the resistance, the RP, the resistance of the parallel connection here. Okay, so now check what I'm gonna do now. Please be careful there. Okay, so now it is gonna be what? RP equals to, I'm gonna use the product over some method, ne? So if R1 times R2 over R1 plus R2. Okay, so now R1, it is 10, it is gonna be 10 times 10 over 10 plus 10, which is simply what? 10 times 10, 100 over 20, so it is simply 5 ohms. Okay, so now check something here. Now I want you to check something. The resistance in parallel, it is equals to what? 5 ohm. Okay, so this one, it is simply giving you 5 ohm. So this is what you have now. So now this is what you simply have. This is the same as saying I have this, and then I simply have what? 5 ohm. Then now I have my what? This 10 ohm here, this bulb, which is 5 ohms. Now as you can see, I found the answer for this, and it is simply 5 ohms. Okay, now check what is gonna happen now. Check what is gonna happen now. 5 ohm and this is 10 ohm. 5 ohm and 10 ohm are now in what? Are now in a series connection. So when I add 5 plus 10, I simply get what? 15, meaning that here I have what? 15 ohms. So meaning that this 15 ohm is now in parallel with this 15 ohm. So already these ones are out. Can you see how you do these things now? So check something. Initially, I had a parallel connection whereby it was R1 and R2, which is 10 and 10. So I found the resultant answer to be what? 5 ohms. So now it was going to be 5 ohm, which is now in series with this 10 ohm there. Can you see it, which is this RL? So now since they are in series, I can find the resultant resistance. So it was now 15 ohm, meaning that the very same 15 ohm, it is now in parallel with this R3. So meaning that I'll have to find the total external resistance. I'll have to do what? Find the resistance in parallel between these two resistances. Is it fine, guys? Please make sure that you understand it. I'm going to explain again. When you are dealing with such questions, especially grade 12 electricity, make sure to interpret it. Very important. Initially, I was given R1 and R2, 10 ohm, 10 ohm. But I found the resistance in parallel to what? 5 ohm. That's why I wrote it like this. But the very same thing was now connected to another resistance of 10 ohm. Now it is the same as saying 5 ohm is now in series with this 10 ohm. But now I can see that the 5 ohm resistance is now in series with this 10 ohm resistance. Now I can write it as what? S1 resistor, which is what? 15 ohm resistor. But at the same time, the very same 15 ohm resistor is now in parallel with R3, meaning that I'll have to find the resultant the resultant resistance in parallel between 15 and 15, so that I can find what the total external resistance of the circuit. I hope it's now clear. So meaning that here I'll simply have what RS equals to, what do I have now, 5 plus 10, which is equals to 15 ohms. Now I can simply find the resistance in parallel. Again, R1 times R2, R1 plus R2. So it is simply 15 times 15 over 15 plus 15. Then I get my answers what, okay, 7.5 ohms. Okay, that's how you simply interpret those types of questions. Very, very important. So now, what is 8.2.2 saying? Now they simply want what? They simply want the reading on the ammeter. Now let's go and check out the what to call the ammeter there. Okay, so now where is the ammeter here? As you can see, the ammeter, it is simply what? The total current there, which is here. Okay, so now since it's like that, and you know that since we found the total external resistance, now we can simply say you have the total resistance there. The external resistance. So this is R external. Sorry, it is not the total resistance, it is simply R external. So now when it is like that, I was given the EMF, I was given the internal resistance, and I have the external resistance, and then now they want the current, meaning that I can simply use the EMF of formula. So meaning that I simply have what? E equals to I, then R plus R. Can you see it? The EMF was 12. The I is the one that they want, the current. And then now this big R is for external resistance. So it is simply 7.5 because we just got it. Then 0.75, 0.5. Can you see it? Now it is simply 7.5 plus 0.5. Let's see. It has to be 8. So it equals to 8I 12, meaning that the current, the ammeter, the reading on the ammeter is simply 1.5 amps. Is it fine, guys? Now I hope you understand. You just have to check what you have. Now they're saying that the power dissipated by R3, specifically R3. Can you see it? Because now they said what? R3, meaning that specifically for what? Specifically by R3. Okay, but now we have to start by checking something there. Okay, we'll have to just checking something there. For us to calculate the power, there are many ways to calculate power, but remember, we simply find the easier way in order to find the power. So now what you can simply start with here, I feel like you can start with calculating the what you call the current on the R3. You will simply have to calculate the current on R3. Why am I saying that? Remember now that our circuit is simply like R3 and this 15 there. So they are now in parallel, meaning that they simply have the different current. They do not have the same current. Okay, so now we'll have to start by calculating the current on R3, because R3 and this resistance, they have different currents. Okay, so this is what you're simply gonna do now. Now we'll simply calculate the current on R3. Okay, but now check something there. Check something. I want you to know that we are gonna calculate it. Let's start. So you can simply, what can you start with? So now, what is the total current? The total current, it is simply 1.5 amps. Meaning that the current on R3, it is simply 0.75. Why am I saying that? Because you can see that R3 and that resistance, they have the same resistance. Okay, meaning that each and every resistance is 0.75 amps, likely because we have the same resistance. Okay, so meaning that the current on R3, it is simply 0.75 amps. But now if you don't trust yourself, for meaning that maybe whenever you think is wrong, you can simply start by calculating the external voltage, then find the resistance find the current on I3. So it is going to be the same thing. So now I'll say P, it is equals to I squared R, then 0.75 squared times what? 15. 0.75 squared times 15, which is simply what? 8.44 watts. Can you see it, guys? That's how you get it, guys. I hope you're understanding this, because electricity is a very, very crucial topic. It's very, very important. You have to understand everything. Okay, so now let's go and do the last question. I hope you are now understanding everything now. Okay, now let's go to the last question. What is it saying? Switch S is now opened. Now this one is now opened now, meaning that the current is no longer gonna go through this R3 now. Can you see what is happening now? The current is no longer gonna go through R3. Can you see it? Because now the switch is now opened. Okay, so now if the resistance of the light bulb remains constant, how will the brightness of the light bulb be affected? Now it is simply going to be what? Increase. Why am I saying that? Remember, you initially had two resistors, right? This 15 and that 15 there. Now we are talking about the light bulb, meaning that the light bulb is that one that you have there. So now, since you have two resistors and the other one is not working, now it is meaning that this one is now bright more, because now it means that this one was now causing it maybe to bright lesser or something. So now it is gonna increase. Explain your answer. The total resistance of the circuit will simply what? Increase, and the current decreases, because the current, it is no longer gonna pass through this resistance. So the current will do what? Will decrease. So let's start. We're gonna start by explain. Now I'm gonna write in short, but you can write in full. So the total resistance of the circuit what? Increases, and then the current what? Decreases, because the current is no longer gonna flow here on this resistance. Can you see what I'm talking about? Then the resistance is gonna do what? Increase. And then what is another mark? The other mark can say the internal voltage will decrease and the external voltage decrease. Interesting, eh? And then now the next one can be the voltage increases and the power increases, therefore the brightness will also do what? Increases. Those are the type of things. You can write the ones that I just told you now. I don't want to write such things, because those are easy stuff. 3-4 marks for mahala. You see how nice it is, guys. But I hope you understood me on this part. It is very, very, very important now. Okay, thank you very much, guys. I hope you enjoyed.